Hello, everyone. Thank you for joining us today, Pittsburgh Java User Group's first session in 2022. So yay. So hopefully this is what we'll continue doing through the rest of the year. We typically try to do this on the second Thursday of each month, which has worked out really well for us last year. So we're going to continue doing that. As you all know, you can continue to get the updates for upcoming sessions using our Meetup group. But if you're also a tweeter, then you can follow us over here at the PG Java Meetup Twitter handle. Speaking of next sessions and just general announcements, we have a YouTube channel now, yay. And all the recordings from 2021 are up. I know a lot of people have asked us offline when these recordings will be available, and we've made them available. They're all ready to be consumed, viewed, watched, whatever. And then on March 10th, we have Jose who will be presenting to us Java 17 features, and it's going to be a live coding session. So I think this is still a very, very relevant topic. I know 18 is going to be released in just a month, but Java 17 is the most recent LTS version. So, and a lot of folks are actually updating to this particular production version or whatever you want to call it. So I think seeing all the features in a live coding session will be really helpful. So join us for the March 10th session. And with that, I'd like to hand it off to our speaker, Dan. Dan, if you could quickly introduce yourself, and the stage is all yours. I'm going to stop sharing.
Great. Thank you. Let me share my screen real quick, and then awesome. We'll be ready to go.
Perfect.
Yeah, so thank you very much. I am out of Colorado, and I'm really happy to be able to zoom in here. And I am head of DevRel at a company called FusionAuth. And we'll talk a little bit about FusionAuth next slide or two, but this really is not a talk about FusionAuth. This is about JSON Web Tokens. And I've been a developer for a couple of decades. I actually wrote Java applets in 1997. That was kind of my first experience with Java. It's a different world now, obviously. And then the last thing I'd say is that the next month's talk looks really interesting. We actually just upgraded, I think it was 2 releases ago. So in December, we upgraded to Java 17, and that opened up some language features. But the biggest thing we saw that was interesting actually was we could easily target other architectures. So we don't just target Intel anymore. We can target the ARM, or I think we even target like some mainframe like Linux 1 on the System 390. So anyway, that's for next month. But today I'm talking about JSON Web Tokens and what Java developers need to know. Real quick about my employer. We are an authentication and authorization platform. We're built by devs for devs. And what we really do is we let you snap in a lot of undifferentiated functionality like login page, forgot password page, user registration, all of these kind of user management things that you need to do right, but they don't really distinguish your application, right? Your application is about the features you build. So we offer a plugin version, and we have a community version that's forever free. And then we also have versions you pay money for that have certain advanced features or that we can host for you. And how that's relevant to this talk is we mint a whole lot of JSON Web Tokens. Real quick about me, who cares? I already gave you my intro at the beginning. If you have questions, I do have the chat, or I will have the chat open. So I got the chat open, and this is a small enough group. I don't know, I think we're at 10 or 12 people now, that feel free to just unmute your mic and ask. And if I go quiet or freeze for a second, that's happened to me in the past, feel free to let me know that too. All right, so what we're going to talk about today, we're going to talk about JSON Web Tokens briefly, and we'll spend a lot of time talking about the problem they were created to solve, so that you have kind of a conceptual understanding of when it makes sense to use JSON Web Tokens. We'll talk about validation. We'll talk about concerns that are common to any bearer token, because JSON Web Tokens are often used as bearer tokens. We'll talk about common problems that you might have with JSON Web Tokens. I call them foot guns because they let you shoot yourself in the foot, and how to avoid that. We'll cover refresh tokens, and then we'll also talk about JSON Web Token revocation. So real quick, JSON Web Tokens are, or JWTs, or they're actually pronounced JWT. That was news to me when I started this job. They are basically JSON objects that are encapsulated and then transmogrified, transformed into something that can be put into HTTP headers. They're an IETF standard, so 7519 is the main one that I've spent a lot of time with, but there's 4 or 5 other standards clustered around there, around how you sign JSON Web Tokens, how you encrypt, how you can encrypt them, what the various pieces of JSON Web Tokens are. 7519 is not a long standard. I think it's like 12 or 15 pages, so it could be worth reading if you want to put yourself to sleep or something. It's really important to note that JWTs can be signed or they can be encrypted. And the vast majority of JWTs that I've seen in the wild or that FusionAuth creates are signed. And the difference is really important to understand. So I want to spend a little bit of time on that. With the signed JWT, you have a cryptographic verification that the contents of the JWT were not changed since it was signed. So it's created someplace and then it's sent someplace else, and then you can verify that the contents haven't changed, but the contents are not secret. So anybody who gets a hold of that, whether they sniff your traffic or whether they get stuck in a log file somewhere, or whether it's in a cookie and someone else can examine that cookie storage, they can take that JSON Web Token, even though it looks like gibberish, and plop it into a bunch of tools online and see the contents of it. So those are signed JWTs. Then there are encrypted JWTs where the contents are actually encrypted. And like what encryption means is that no one without the key can see the contents. Those are a lot rarer. I've actually never seen one in the wild, but they do exist and the standards are there for them. So JWTs are often used, and the focus I'm going to talk about today is this. They're used as stateless portable tokens of identity. What do I mean by that? I mean that they are stateless in that they are self-encapsulated. You can tell the validity of them via the signature without talking to any other server. They're portable because they are wrapped up in such a way that they can be put into one of the main means of transport for software today, which is HTTP. So they can be put in headers, they can be put in cookies. You can, though you shouldn't, put them in query parameters. You can put them in form parameters because they're a really nice string. Even though they decode to have like curly braces and look like normal JSON, they aren't wrapped up that way. And then they're used as signifiers for identity, and we'll talk about that in a little bit. Because of those, the way that JWTs are often used, they're really great for APIs and microservices, because you can have some service out there authenticate users, and then the users can carry, their clients, to be more honest. Users aren't carrying any JWTs around, but clients like browsers or native apps can carry it around and then present it to APIs or to microservices and say, hey, this is who I am. And that microservice or that API can know that that JWT was signed by the originating authenticating server, and without ever talking to that originating authenticating server, and then can look at the JWT. And again, we'll see pieces of JWTs in this presentation, but they can look at that JWT and say, oh, this person has role admin, or this person has this ID, and then they can deliver data based on that. JWTs are produced by a lot of different identity providers. FusionAuth is one of them, but Auth0 is another, Keycloak's another. There are many different IDPs or identity providers that produce JSON Web Tokens. And they're widely supported, not just in that sense of they get produced a lot, but there's a lot of open source libraries out there. There's a lot of people who know how to use them. There's a lot of articles about them. So they have been around. I think 7519 was codified in 2017. So they've been around for 5 years or so. Obviously, in standardized form, they were there beforehand, because that's how the IETF works. It doesn't take standards out of thin air. It codifies existing systems. All right, so let's talk about the problem that might cause you to reach for JSON Web Tokens, because we're engineers here, and use the right tool for the job is one of my favorite sayings, and JWTs are not always the right tool for the job. So I'm going to talk about the job that JWTs might be a good tool for. So right here we have kind of an over-engineered to-do API, a to-do app, excuse me. So over on the left here, we have our clients, right? We have a web browser, we have a mobile device, we have a user API, and we have a to-do API. And the whole point here is we're going to create an app that lets me mark down things that I should do. And then when I've done them, I'm going to check them off, right? So it's a to-do list, but it can be used by different clients in different places. The user API is going to handle user data. So we have users, we have roles, and within this to-do app, you could have things like, there might be a super admin role, or there might be, you might be able to sell a family to-do app, a family plan. So there might be adults that can give tasks to kids, but kids can't give tasks to adults or something like that. So we're going to need to have roles to map those business rules. And then we have our to-do API, which just stores to-dos, basically. It's probably a CRUD interface. And this table here is what the to-do data store is going to look like. And the only important thing to note here is that the user ID cannot be a foreign key in this situation. The user ID can't be a foreign key because if we go back here, there are two distinct data stores. So you can't have a foreign key across across the network like that. So how do people interact with these to-dos or this app? Well, what you do is first you're gonna need to log in, right? This is pretty standard. We're not gonna dig into how or why you log in or the mechanics of login, but we're gonna log in by posting some information, probably a username and password, but it could be other things, to the user API. The user API will validate that information, right, and verify that I am who I say I am, and then it will look up my data in the user's database. Suppose I'm user ID 42, and it will encode that as JSON and pass that down to my device. So now the device knows who I am, and it has some information about me, something that might look a little bit something like this, right? My ID, my name, an email address, some roles, maybe some other information, but it doesn't have any to-do information in here. So we need to get the to-dos. Well, where do you go to get to-dos? You go to the to-do API. So here the client peels off that user ID that user ID of 42 and makes a request against the to-do API and says, please give me all the to-dos for user ID 42. The to-do API looks that up in the to-dos data store and then passes that back as JSON. Easy peasy, right? Actually, huge issue. Huge issue. Does anyone want to guess what the issue is with this problem, with this situation? You can put it in chat if you want. You can say it out loud if you want. All right. No guesses, no takers. The issue is that a malicious client, exactly. Frank points out that the traffic listening might get the data, and that's true if you're not over HTTPS. One says authorization, and that's pretty much right. The issue is that a malicious client can look and say, hey, I just passed a URL that ended in user ID equals 42, and I got back user ID 42's to-dos. I wonder what happens if I pass in user ID 1. And the to-do API has no knowledge of who I am. It just blindly hands back whatever that user ID is. It hands that back to the client. And so things like, my to-do to go get milk after this talk aren't going to be protected. But I mean, all jokes aside, this is actually a serious issue because you don't want me to see other people's to-dos or other people to see my to-dos. So what can we do? Well, that is a naive approach. I hope you never implement that. That is just shown to kind of give an idea of the problem. This now is actually an approach that works pretty well. So this is the opaque token approach. And the idea is the user API hands back not just user data, but a token. And this token is like a long string of digits and numbers. It just has to be high entropy. It doesn't really matter what it is. It doesn't represent anything other than a particular login event, basically, in the user API. Passes that back to the client. The client then passes that token to the to-do API. And that to-do API says, I'm not sure what to do with this, but I know where to go. And it can talk to the user API and present that token. Now that token means something to the user API. It means this user data, right? And so the to-do API gets back user data, and it is importantly from a trusted source, right? If that token is iterated with or messed with by a client, then the user API is going to hand back a 404 or 403 or something, and the to-do API will know that a client was doing something wrong. But if it's a valid token that's actually been created by the user API, the to-do API will get back real user data, and then it can use that to look up the to-dos and pass those to-dos back to the mobile device where it can be rendered. So this is one approach, and like I said, it's called the opaque token approach. There are some benefits to it, but there's some costs too. One of the costs is that you have to have a user token mapping, and you have to maintain that in the user API all the time. It can be very chatty because anytime an API, and again, we only have one API here, but in a real application, you would build out more than just one API, right? You'd have, or we have two here, but you'd build out a to-do API and a reminder API and an email API and a number of different APIs all kind of coalescing to form your app. So every one of those APIs that's not the user API is going to have to, anytime it gets a token that represents the user, talk to the user API. So that's a pretty intense coupling. So this is where JWTs make sense. So instead of creating an opaque token, the user API creates a JSON Web Token, and it passes that to the client and then passes that to the to-do API. Now the to-do API, because of the nature of JWTs, can examine the contents of that JWT and trust them if the signature matches, if the signature is acceptable, trust that it has been modified over the wire, and therefore it can just take the information it wants out of the JSON Web Token and look it up in, like, get a user ID out of the JSON Web Token and look up the user's to-dos and then pass them back to the client. So that's really where JSON Web Tokens make a lot of sense. They can be signed, and there's two different ways to sign them, either with a public or private key pair using something like RSA, or with a symmetric key. And we'll talk about some of the strengths and differences of those. As I kind of alluded to on the previous slide, they can be validated without the to-do API ever calling the user API. It doesn't need to have any network access if you set things up correctly to the user API. And the other thing that's more beneficial than a token, opaque token, is that you can put whatever you want into a JWT. You can put roles, you can put business domain specific things like, whether this is a premium user or if they have, like I said, family members, right? Like who their family members are. You could put that all into a JWT if you wanted to. So enough kind of talking about the scenario. Let's talk about JWTs themselves. This is a JSON Web Token, and there are three parts to any JSON Web Token. There's the green header, the blue payload, and then the tan signature. Let's take each of those apart. They look like garbage, but it's actually just base64 URL encoded JSON. So the header looks like this when you decode it. So that's what I mean when I say that it's, even though it looks like this and it looks like it's encoded and everything, this is a signed JWT, and anyone who gets their hands on it can see the payload, they can see the header. So the header here just has metadata about the JWT, like which algorithm was used to sign it, what the type of the JWT was. The JWT body is where things get really interesting. The keys of the JSON web, of the JSON object, are called claims, and they are talking about the principal, which is the person that this JWT was issued for. And we'll go over some of these claims in a little more detail a little later, but the important thing to note here is that they don't have to just be JSON primitives or JavaScript primitives, although there are plenty of those. They can also be richer objects, like you can see that roles are an array. So you could do an array of arrays, an array of objects. Anything that can be represented in JSON can be can be encapsulated as a JWT. So finally, we have the signature. And as I mentioned, this could be a symmetric algorithm, or in which case there's a shared secret between the creator of the JWT and the verifier of the JWT, or this could be a public-private key pair, could be signed using a public-private key pair. And the important thing about the signature is that it is what validates that integrity. So how the signature is created is you take the header and you take the payload and you stick them together, and then you basically run a cryptographic algorithm across them with a secret, and then you get a hash essentially, and then you URL encode it, base64 encode it, and then you stick it onto the end of the JSON Web Token. So that's how you create the signature, which chances are you won't be doing very much of that, but you also can do the reverse operation, which is you take the header, you take the payload, and you run that same cryptographic operation. And if you get a signature back that matches, then you know that you can trust the contents of the JSON Web Token. So let's talk about validation of the JSON Web Token. And this is assuming that you're the to-do API, right? So someone's handing you a JSON Web Token. What do you need to do to make sure that you're taking care of things? The first thing you want to do is validate the signature. And I just talked about kind of that process, but you should never do it yourself. Use a library. There are a ton of open source libraries out there. I have some, towards the end of this presentation, I have some links to Java ones, and I think there's one included with Spring. You do not want to write your own JWT verification library. It's error prone. You can make mistakes. You want something that's open source that other people have looked at. After you've verified the signature, now you know that you can trust the contents of this JSON Web Token because the signature matches what the user API essentially created, right? You know that those match. And then you need to take the next steps, which are validating the actual claims. And there's three that you really need to look at. So this is the payload that we saw previously. First, we want to look at the issuer. So the issuer is who created this JSON Web Token. And I've seen it be a domain name. I've seen it be a string, a UUID, a URL is pretty common. It doesn't matter what it is, as long as the to-do API and the user API agree on what it should be, right? The user API, basically the issuer represents the user API. It's some string that represents the user API. And you obviously, if you get a JSON Web Token that's not from one of the issuers you expect it to be from, then you don't want to move forward with processing it because you're not sure who created this thing. Next is the expiration time, and JWTs are time bound. So that means they're valid for a certain lifetime. And that's because they're stateless, because they're self-encapsulated, if you didn't time bound them, they would be good forever, which you don't want any kind of credential data to be good forever. So JWTs are good for a fixed period of time. And if you see an expiration time that is in the past, again, it's an invalid JSON Web Token. Don't go forward. This is not a JWT you should process. The last claim that you should check most of the time is the audience claim. And this represents the to-do API in our diagram. So the issuer is the user API, the audience is the to-do API. That means that the audience is what this JWT was created for, like who should consume this JWT. And this doesn't have to just be a string. It could be an array if you want. And that's important because you could imagine that as we build out this application, we might add an email API, and maybe there's an accounting API or a billing API. And you could imagine that there's probably an admin role that's applicable to the accounting API and an admin role that's applicable to the to-do API. And you probably don't want the to-do API to accept a JWT that was created for the accounting API, or more importantly, you don't want the accounting API to accept a JWT that was created for the to-do API, because that might lead to escalated privileges, which at best is a bug, and at worst might cause your billing API to send money to some overseas, Swiss bank account. So let's look at some code real quick. So this is code about validating claims. So this is example code I wrote, so not super complicated. This is all available under the Apache 2 license, and the GitHub repo is going to be included in this presentation. Again, it's in those links that I mentioned at the very end. And so because it's demo code, we're going to pretend that lines 18 through 37 are the, or 19 through 37 are the user API. So this is where we're creating a JWT, and we're using an open source library, and we're setting things like the issued at time and the audience and some other claims. And it's gonna turn into a string. And then the really interesting piece here is lines 39 on, which is, again, we're the to-do API. So we're accepting a JSON Web Token, and now we need to verify that it works, right? And so we're going to check the signature, and then we're going to check a couple other things. One thing that's worth noting is a lot of libraries will take care of the expiration time for you, but very few libraries will take care of checking the issuer, checking the audience. So you usually have to do that yourself. So here we are verifying it using this on line 46. That's we've previously, on line 40, we've set up a verifier. And in this particular case, we're doing symmetric signing algorithm. So we have a shared secret. So not enough many secrets is my shared secret. And we're going to, on line 46, we're going to verify it. And so that makes sure the signature is taken care of. And this is where you should, again, lean on a library. And then lines 47 and 48 are where we actually check to see that the audience is who we think it should be, and the issuer is who we expect it to be. So this is just going to check and see. So you can see here's our generated JSON Web Token, and then this is what it turns out to be, right? This is the structure. So you can see we have roles, we have premium user. Let's change it so that it fails to verify. And we'll just do that by saying this actually for a different audience. We expect ourselves to be start with 128, but our JWT actually starts with 238. So we do this. Kablooey. We still generate the JSON Web Token, but right here we have invalid claims. And that means that whatever data we were going to do downstream, whatever operation we're going to do downstream, based on the authorization that this JWT had, we are not going to do. Any questions about the code?
Dan, I do have one question, and this might be silly or I must have missed it earlier. So when you create a JWT, right, do you usually create, so for example, if you go up and look at the user API portion of it, so is the audience ID always going to be one? Like, do you always create a JWT for just one audience? Like if I'm the user API, would I create a JWT only for to-do, one for email, one for notifications, reminders? Is that how it works? Or you can include multiple ones? And I can't understand that difference, I guess.
Yeah, so you could. So you have a couple options here, right? And it depends on the level of granularity you want. So one thing you could do is you could say, let's say you have your to-do API and you have like an email and a reminder API. You could say, hey, this is all part of the same app. We're all going to be the same audience. And in which case you would create one JWT, and then you would have different things. Another thing you could do if you were uncomfortable with that, you could say, well, this user, they're signed in and they're going to need access to these 3 different APIs. I'm going to create an audience that is 3 different UUIDs, and then it'll be an array, and then they can each check to see that they are included in that audience.
Okay.
That would be an option.
Okay, so it can be a collection at that point. And each audience can at that point verify that they are part of that collection, that array, basically.
Yep.
Okay.
And that would change, this from being equals to being like an uninclude
Oh,
or
yeah.
an index of. But
Yeah.
that's nuts and bolts.
Understood. Yeah. For
Yep.
sure.
Cool.
Thank you.
Yeah, great question. Anything else, or should I move on? All right. All right, so let's talk a little bit about bearer tokens. And this is not, this section is not specific to JSON Web Tokens, to JWTs. Bearer tokens are any token that is like a car key. That's the way I think about it. Like if I hand my car key to this valet, he can pop it in the car, turn it on, and drive away. The car key, the possession of the car key is what gives him access to the car. So in the same way, the possession of a JSON Web Token or any other bearer token gives you the ability to present it to an API and get access to that API. That's great if you are the right person, but if you're a malicious actor who's found a JSON Web Token, right, who's intercepted a JSON Web Token conversation, or has, if someone stored a JSON Web Token or any other kind of token in a publicly accessible place like local storage in the browser, and you find it somehow, then you can present that JWT or that token to the To-Do API, and the To-Do API has no way of knowing that you're not the right person, because it looks at the JWT and it says, oh, it's signed correctly, and the audience checks out, the issuer checks out, all the stuff checks out. It doesn't know who's presenting it. So that would obviously allow a bad actor to get access to your to-dos or your other data. So you need to take care of your, and actually real quick, I want to say there are some solutions out there that aren't widely deployed that take care of actually cryptographically binding the token to the client. And that would be like a key that like is a biometric key and like knows my thumbprint, right? And so a car won't start if my thumb isn't the one turning it over. But that's not widely deployed. That does exist. And if you have questions about that technology, I can like at least point you to the specifications. With bearer tokens, you want to be careful about how you store the token. You want to prefer server-side storage if you can. And this is known as the backend for front-end pattern. And so basically the idea is basically the token stays on the server side, it never goes down to the client. And then the client and the server are just matched up by session technology, which is a well-known, well-understood, pretty old technology for matching clients and servers. Sometimes people aren't happy with that because basically it means that you're kind of proxying everything through that one backend for front-end server. And so they say, well, can I push it down to the client, like the browser or a mobile app? And the answer is yes. If you're doing that, you want to make sure that you push it down in a way that's relatively secure. You can push it down as an HTTP-only secure cookie in the browser. That protects it from JavaScript, like XSS JavaScript kind of rummaging around and finding it, because if it's HTTP only, JavaScript can't get access to it. But yet any requests that are made to the domain the cookie is for will receive that cookie along with it, right? So it can still be captured by the To-Do API, and the To-Do API can look at that cookie and validate the token. That's not perfect, right? Because you actually have physical security issues. If someone leaves their session open on the browser in the public library, someone else can wander in and see the cookie and see the token at that point. So it's a set of trade-offs there. Similarly to secure HTTP-only cookies in the browser, you can also store tokens in secure storage on mobile devices as well, which again is just kind of a secure enclave for things that other applications or the operating system shouldn't have access to. So let's talk about some common issues, or what I call the foot guns. Yes, as Srisha says, please, Srisha, please do ask questions if you have them. Let's talk about mistakes that people make sometimes. First of all, JWTs are pretty powerful and it's cryptographic work. So there's tends to be a lot of configuration options. Use a library and make sure you verify your claims the way that we talked about. It's important to note that the strength of JWTs are that they can contain arbitrary JSON data, but the downside is that there are no secrets. And if anyone else finds them, finds a JWT, then they can take it and URL decode it and see what's in there. And I actually did that just today. I was making a reservation at a restaurant and I noticed there was a JWT in the URL and I was like, I wonder what that's all about. And I didn't take a screenshot of it. I should have, but it was basically saying like something about ticket number and order number and whatnot. So it didn't have a lot of useful information in there, which is good. You know, you don't want to leak any data about your internal systems if you can help it, because anybody who can look at a JWT can actually see the contents of it. So, you know, don't put a social security number or any secrets in there. It's fine to have references to server-side things like the UUID for the audience or the subclaim that we saw in the previous JSON Web Token, but you don't want to have anything that's meaningful, because if someone can find it, that could be a security issue. Another thing to be aware of is if you use symmetric keys, pick a nice long random key. There is open source software like this that will actually brute force and reverse engineer the key from just a signed JWT. So if it's signed symmetrically, then it can just kind of try to figure out what that signed JWT is, or sorry, what the secret is. And then once they have the secret, they can now create JWTs that look indistinguishable from those that are created by the user API. The JWT specification allows a none algorithm where no signature is required. This turns a JWT from looking like this into looking like this. There's still 3 clauses, but the last one is empty. And the header changes from looking like this to looking like this. And the honest truth is that this is scary, because basically anybody who if you were to do API accepts unsigned JWTs, that means that anybody who has access to that can craft a JWT and give themselves whatever payload they want. You know, super admin, super admin, super admin. Doesn't matter what it is. They can present that to your JWT API, and your JWT API will merrily accept it. So problematic to say the least. Not just talking about unsanitized input, we're talking about unsanitized credentials, which is obviously not good. So when in doubt, do not ever accept, even though the specification allows this, do not ever accept none, right? You shouldn't generate none. You shouldn't accept it. So Chirag asks, is there any book recommendations to understand these things in detail? So I would say that I have not run across any book. I'm actually working on a little ebook that contains a lot of this information. The FusionAuth website has some information. The specifications are probably where I would start, but I'm not aware of any published book that talks about this stuff. All right, so let's talk about signing with asymmetric key pairs. And a lot of my examples before, and my code example, you know, there was a shared secret. And that means that the user API has to, you know, there's some string that it uses to sign the JSON Web Token, and then the JWT API has to have access to that exact same string. Now, it's easy to do that when they're both in memory in my sample app, right? But it's a little harder in the real world. How do you handle deployments? How do you handle security? Because again, you need to secure the to-do API at exactly the same level that you would the user API, because if anybody gets a hold of that string, they can now sign JWTs that are indistinguishable from those that are created by the user API. So asymmetric keys actually give you, oh, I'm sorry. Triggers about Philip, I'm sorry about that. I'm not trying to trigger anybody. Excuse me. So asymmetric keys let you basically have no shared secret. And we'll talk a little bit about the nuts and bolts of that. But the reasons why you might be interested in that are that it scales organizationally, because now you can have one department own the user API and then publish, basically sign things with a private key and then publish public keys. And then you can have other departments build the to API or the reminder API or any other APIs, and they can just find the public key that corresponds to the private key that was used to sign the JWT. And they don't have to be shipping around any secrets. In fact, they don't even have to be at the same company. They could be at totally different organizations. And as I also mentioned, there are security issues as well, in terms of just needing anything that has that shared secret needs to be really, really secure, because that's the key that lets you sign JWTs that are the markers or are the keys, the keystone of the integrity of the JWT system. However, asymmetric keys, there's no such thing as a free lunch. They're more complicated to understand, and they are slower. How much slower? Depends on the language, depends on the algorithm, depends on whether you're signing or you're verifying. But I've seen between 2 and 10 times in the tests that I've done. So how does this work? Let me kind of walk through this. We have our user API, and it generates a JWT, and it signs it with a private key. Passes that to client. Client passes the JWT up to the to-do API. The to-do API, to verify the signature, needs access to the public key. Now, there are a couple ways you could get it. One is you could actually have that be deployed with the to-do API. And this has some benefits, because now the to-do API doesn't need any network access at all. It just knows that this public key corresponds to this private key. But you lose a little bit of flexibility. If you want to rotate keys, it becomes a little tougher because it becomes a deployment operation, or you have to package up a bunch of public keys. Could be done. Another option that's pretty common is the user API basically publishes those public keys to a well-known endpoint. And then the to API just periodically will go out and grab those keys and say, oh, here's a list of all the public keys, and I'm gonna store that. And then when something comes in, I'm gonna look and see whether it was signed with the private key that corresponds to the public key that I know about. If it doesn't, then I'll go out and grab the public keys again. How do those keys look like? Well, they look like this. This is the output of that JWKS.json, and that's another standard. This is pretty busy and pretty small. So let's just extract a little bit of interesting information. Each of the key entries looks like this, and the relevant keys or the relevant JSON object keys are alg, which is the algorithm that was used to sign it. So in this case, it's RSA 256. We have a key identifier, which is just a random string that identifies basically the private key and the public key pair that were used that should be used to validate the signature of this JWT. And then we have the public key. And so that's what the X5C is. And that's an array because you can have a chain of public keys. I usually see it just with one, but it could be more than one. And then inside the JWT that the to-do API gets is going to be that key identifier. And so that's how it knows which public key to use to verify the JWT was signed correctly. So let's talk about refresh tokens. JWTs are really supposed to be short-lived. We're talking about seconds to minutes. Refresh tokens can be longer lived, and they can be used to basically create new JWTs without a user re-authenticating. If we imagine a world without refresh tokens, you have a couple of unsavory choices when a JWT expires, or a couple of unsavory choices in general, right? One, you can make the JWTs short in lifespan, And then when a JWT expires, remember the to-do API, if it sees a JWT that has expired, if the JWT's expiration time is in the past, the to-do API should not give up any to-dos. So what does the client do then? Well, it can't get the to-dos that it wants, so it has to send the user to re-authenticate against the user API. Now, if your JWT's only good for 2 minutes, I don't know about you, but there aren't too many applications I'd be happy using where I had to re-authenticate every 2 minutes. That'd be a real pain in the butt. The other option is that you could make your JWTs long-lived and say, I'm not going to listen to Dan more. I'm gonna go my own way. I'm gonna make my JWTs good for 5 years. Well, then you have this tremendous security risk, because once I've logged in, I have a JWT that's good for 5 years. And if I ever lose that JWT or anybody ever finds that JWT, they can represent themselves to me. They can represent themselves to that to-do API as me for 5 years, which obviously is a huge issue. So the refresh tokens allow you to kind of split the difference between these two problems. How do they work? Well, basically, we have the client at login says, hey, I want a refresh token. The user API doesn't just create a JSON Web Token, it creates a refresh token as well, indicated by the RT. And those both get passed down to the client. The client stores them both securely because the refresh token is just as valuable as the JWT. And then it presents the JWT to the to-do API. And let's say our JWT is good for 5 minutes, okay? So for 5 minutes, you know, I'm adding tasks and I'm updating tasks, I'm marking them off and I'm reminding myself about them, and I'm, you know, just living large, doing my task thing. And then at 5 minutes, the to-do API, because every time I make a request to the to-do API, the to-do API is doing all those validations, right? It's checking the audience, it's checking the issuer, it's checking the expiration time. At 5 minutes, the expiration time is done, and it's going to say, hey, Dan, no more. I'm going to send back a 403 forbidden or a 400 error, some HTTP status code that says, hey, this is no longer an acceptable JWT. The client can now catch that and say, oh, I made this request, but there was an error, but I have this refresh token. Maybe it's because the JWT was expired, and I'm going to pass the refresh token back to the user API. The user API has a lot more context about the user. It knows if I've logged out. It knows if I have paid my bills, if this is a premium app I have to pay money for. It knows if I'm still logged in and I have an active session. If that latter is the case, then it can say, okay, I'm going to create a new JWT good for another 5 minutes. And it passes that back down to the client. The client can then present that JWT to the to-do API for another 5 minutes. So basically, we've silently re-authenticated, and yet we've still maintained a really nice, tight, short-lived JWT lifetime. Then you may say, well, can't refresh tokens be abused as well? And the answer is, of course, yes. If refresh tokens, they're typically good for days or months, or it could be good for years. But in the latest, it's not a specification yet, they're working on it, they recommend actually having refresh tokens be one-time use. So actually, you present a refresh token, and you don't just get back a JWT, you get back a JWT and a refresh token that's new. And so every 5 minutes, you're getting a new refresh token. So that, again, you still run some risk of someone stealing a refresh token and getting a JWT. But the user API can be smart about things, and it can actually do things like notice if a refresh token has been used twice and not allow for any more refresh tokens in that same refresh token chain, or send an alert or something like that. Whereas you don't have a lot of, you don't have that knowledge with the JWTs. So logout, basically in a JWT-based system, is revoking the refresh token. So how does that work? Basically, the client logs, the user clicks logout from the client. The client tells the user API, hey, this refresh token should no longer be valid, and then it destroys the JWT and the refresh token on the client. That's basically how logout works with JWT-based systems. which kind of begs the question of, well, what if there's a JWT floating around there? What happens? And if the JWT's good for 5 minutes, then even after logout, you have a possibility if someone's stolen that JWT of 5 minutes of access. So can you revoke them? The answer is sort of. There is actually a specification out there called 7009, which allows you to manually revoke JWTs. But basically, if you go down that path, then you basically have a situation where you're essentially tying everything to the user API again, because you basically have to continually ask, is that JWT revoked, by calling out to the user API. So you fall back into the opaque token pattern we talked about and all the advantages and disadvantages of that at the beginning. So let's talk about other ways to revoke a token. Let's say a user's JWT has been stolen, and one option is to rotate keys. So if you rotate a key and you delete the key that was used to sign the JWT, right, from that list of public keys, then suddenly that JWT won't validate, right? Because it won't be on the JWT, the key that was used to sign the JWT is no longer on the list of public keys. And so it can't be, the signature can't be valid because the corresponding public key can't be found. That's a big thing, because that doesn't just invalidate one person's JWT, that invalidates every JWT that was signed with that key. Now, it could make sense in certain security situations. It could make sense. Another option is what I call the deny list. And so what we do here is on logout, we fire off a webhook to all of the interested APIs in our system, and they maintain a cache of basically JWT IDs that are invalid because the user is logged out, because this refresh token has been revoked. And so then, as part of their validation process, they don't just check the issuer, they don't just check the audience, they don't just check the expiration time, they also check against this hash of revoked JWTs. And again, this is not awesome. This is basically pushing state down to all of the APIs, but it is a solution that will work, that will not give you that 5 to 10 minute window, or that 5 minute window in this case, of a JWT being valid and useful after users logged out. Come up on the end here. Thank you all. JWTs and Java, what are you trying to accomplish? If you're trying to generate or parse JWTs, use the JWT library. There's a lot out there. FusionAuth -JWT is one. It's open source. Doesn't cost a penny to use. I think it's Apache licensed. And then if there's authorization needs, right? If you're talking about the do API, you want to build a filter, or a lot of frameworks have filters already there for you. Like Spring has a JWT authentication provider that just kind of plugs in, and you tell it what INs you're expecting. I think you can tell it what issue you're expecting as well. Here's some tools, and I will make this available as a PDF so that you can share it, and then people can look at these links themselves. I don't expect you to write these down, but it's just a couple of tools around JWTs, and it also includes that the second point is that code that I walk through with more examples. And that's it. Thank you. If you want to learn more about JWTs and OAuth and how we at FusionAuth think about OAuth, you can actually download a free ebook. We will ask for your email address, but I think it's 100 and some pages, and it talks about all the different OAuth grants and all kinds of great stuff. I will say that we are hiring at FusionAuth, so if you're looking for a job, feel free to take a look at that URL. And if you have questions about cat memes or to-do applications or JWTs or OAuth, there's my contact information. So thank you all, and I'm happy to take any other questions you have.
Yeah, I had one question. So earlier you were talking about two types of JWTs, right? Signed and encrypted, and that the vast majority are signed, and all of the JWTs I've worked with have definitely been signed. But I guess my question is, why are encrypted not as frequently used? Is it just convenience, or are there other reasons involved?
I mean, I think that, and I should say, like, that's just in my experience, right? Like, I don't know. I would think that encrypted would be more computationally intensive. And the other kind of issue with encrypted JWTs is it's similar to the issue with symmetrically signed JWTs. With encryption, I mean, I guess you could use public-private key encryption, and so you would not have the issue with distributing it, because that's what I was thinking. If it's symmetrically encrypted, you're going to have that same issue of you have to get the secret in the consumer and the producer. But if you use public-private key, I don't know. Maybe it's that people are just using JWTs as a way to ship around IDs, and then they're just going against backends and they don't need to ship around the actual information that would need to be hidden. But I don't have a great answer for you.
Yeah, that's probably a good insight. But yeah, I've definitely seen the same thing. I don't think I even knew about encrypted JWTs. Like I knew all of the ones I've interacted with have been signed so far.
Yeah. Yeah, it'd be a fun project to do sometime, is just like create an encrypted JWT somehow. And I'm sure there's software out there to help you, but I haven't seen a lot of it. So
yep. Yeah, if anyone, go ahead, Sarisha.
I had a follow-up question on your question, Renat.
Yeah.
So would the third class, which is the signature class, change if it is encrypted? Like it would look different, or would it always be the same three, whether it is signed or encrypted JWT?
Great question. So, and again, this is just based on me reading the spec. My understanding is that it's actually, there's 5 parts for a encrypted JWT.
That would make sense. Yeah.
If you ask me what those 5 are, I will say, go look at the spec. But
yeah,
I do know that, yeah, it looks a little bit different.
Okay. Yeah.
Of course.
Perfect. I absolutely love this presentation. It's such a fundamental topic that we deal with every single day, but this was an awesome session. I thoroughly enjoyed it. It's a good, like, back to the basics, but not really. It's much more than that.
Yeah, I mean, I think it's good to learn more in-depth info about things we use often, and potentially never look beyond the surface.
Right. And I never came across this in like my college days or whatever. But anyway, this was recently introduced, so my college days are not relevant, I guess.
Sarisha's dating herself.
I'm just like, yeah, dating myself. That's right. But yeah, anyone else have any questions? Thanks a lot, Dan, for this awesome presentation. Great.
And thanks, Amir. I appreciate that too. You put that in the chat. So yeah, thanks. And feel free to reach out, and really appreciate it. And I will put in one pitch, because I am a fellow meetup organizer. You should absolutely talk to Meetup. They're super fun, super easy to do. And I bet that the organizers of Pittsburgh Jug would be happy to help you out. So it's a really good way to learn a topic more in depth.
Absolutely. Thanks a lot, Dan. And that was a great nudge to our audience. But we end up seeing the same set of folks join our Pittsburgh Jug as well. So that's always good to see, our audience growing and all of that stuff. So I think from Renat, from our end of things, we'll make this presentation available soon. And Dan, if you can share those slides with me, or if you can just add a link in the meetup itself, as a comment, that'll be even awesome, if that's better for you.
Yeah, I can do
us,
that.
I guess. Or if you want to share it with me, I can add it as a comment. Either way works, since you're already registered on the meetup. But I guess that's about it. Thanks a lot, everyone. And see you all on March 10th.
Yeah, March 10th. And we'll definitely upload this and share it with everyone once it's up there.
And subscribe to our YouTube channel. Oh my God, I can't believe I'm that person now. But yeah, please subscribe to our YouTube channel so you'll get the notification of when Dan's video is up there. Anyway, cool. Now we'll say bye. Bye.
Thanks, everyone.
Good night. Bye.